Now let me see if I get it over here. Huh? Well, there's Denise and St. Patty. I guess I didn't sign into Mecca. Oh, there's live.
Okay, there we go. 7, 6.
The problem is now they got ads too. Okay. Now, what you have to realize is what they call latency. Whatever you see and hear here is at least 20 seconds behind that. One, two, three. One, two, three. Say, keep talking about
1,
it.
2, 3. 1, 2, 3.
Anything coming up there?
1, 2, 3.
1, 2, 3.
1, 2, 3.
It should come up. 1, 2, 3. Let me see if I didn't turn it on. One,
2, 3.
I don't know.
1, 2, 3.
1, 2, 3.
I do see it there.
Coming up here, but
1, 2, 3.
see if you get closed captioning.
Let's see.
I can't see all that. Is it anywhere down here?
Do you want me to see?
You're not seeing the whole thing, I don't think. Bring it up. There.
Share
Is
screen.
closed captioning?
No, I don't. Oh no.
Okay, let me see there a minute.
It is hearing the volume because you see how it's turning green? The dots right here. It can hear us.
In stream, we don't want to do that. Mute, we don't. Well, I don't know why it's not coming up. See if you turn the sound on here, see if you can hear it. If we can hear it, it's okay. Here.
Oh.
Pull more. 1, 2, 3. Sound?
It's catching up.
Yeah. Well, I don't know why it's not coming up.
Yeah.
Okay, then pull it down so you just turn the sound on. No, here. See if you can hear it. Almost. Yeah, there. So just so we can check it is all.
Okay.
Okay, bro. I guess we're ready. Okay, we need to set over here. Okay, you need to set there. And as soon as we're ready, do a switch.
Where do you want Roy? Roy, go sit
Sitting
him.
in that chair. But we're not use those for the time being. Just set them somewhere. No, not there. That'll be in the picture.
Sit right
Here,
there.
put them down here, boy. Here.
Where do you want Roy?
Okay, no, I want you here. Roy there.
Sit right here, Roy.
No, you're there.
Yes.
Okay, we're live, so basically we might have to stop midway and redo it, make sure that we got it right, because I'm not sure where the glitch was. But anyway, basically what I want to do is start now. See if you can find my thing again. Live transcript.
Live transcript.
I have people trained in all that, but obviously none of them are here. So, okay, Roy, so push that magic button, the one I showed you, and that will switch the furthest one over. Yeah, there. Okay, there we are. And Roy, take the camera and move it so she's in there a little bit more. It's the top one. The other way. There you go. Okay. Look good. Look good. Okay. Hello. We're here from Central Texas. This is a International on the Moon night. International on the Moon again night 2024 that we have done now for several years. We're doing this a little bit different. See how that's 20 seconds off? We're watching our monitor here. The monitor's got a latency of 20 seconds. So anyway, what we're going to try to do tonight is something fairly sophisticated. The world of astronomy has changed since we were on the moon many years ago. I was live and I saw all that. So some of it I was outside of the country for, but people out there were watching it too, but we didn't have U.S. channels. I spent 5 years in Panama, Canal Zone, Panama. So anyway, I did see all the real work done on Apollo, and I'm very familiar with all the missions and what they accomplished and how they did it. So now we've got a new mission, and it's a little bit different. The last time we were on a mission of beating Russia to the moon, and we did. So at that point then, what Russia did is backed off and took over the far side of the moon. So the far side of the moon that we never see, a lot of the names there will be Russian, but there's a lot of other ones too. In fact, the Chinese spaceship that just landed last week did a tremendous good for mankind, landed on the far side of the moon, and it actually landed on Aiken crater. Aiken was one of the astronauts on Apollo, I believe it was 17. So this crater was named after him. So there are some craters on the far side of the moon that are named after NASA's astronauts and so on. So anyway, what we're going to try today is, in addition to being totally new, the mission on the moon is totally different. We're spending about $1 trillion, if you can get that wrapped around your brain, to put a man of color and a Hispanic female on the moon. And that was supposed to be this year, but we are already far off schedule, and it will not occur this year. There's Artemis 1, which was already accomplished, Artemis 2, which is what we're waiting on right now to go up, which will go around the moon, but not land on the moon. And then after that will be Artemis 3, where we'll actually land on the moon. Now, we are in a space race for sure with China. They have successfully put two very fine missions on the far side of the moon. One of them last week was groundbreaking in what they did. They're attacking this, getting the moon a little bit different than we are, and they probably are further ahead than we are on it, or at least it appears to be. So instead of going around the moon, the equator, most of our missions for Apollo were in the northern hemisphere. If you understand the Earth, we know what I mean by northern hemisphere. Most of the missions now are in the southern hemisphere because they found water down there, and we badly need water to do the things we want to do on the moon. So we are going after spots to land on the southern hemisphere. We are on the near side, and at this point, it said China is zeroing in on the far side. So you do have to increase your knowledge of math and physics and also dynamics, orbital dynamics and orbital math, because now what we're doing is we're going around the pole, North Pole to South Pole, which is totally different than going around the equator. If you equate that to the Earth, going around the equator is where we all have the geosynchronous satellites that brings television to the world. They're 22,000 miles up in a geosynchronous orbit, which means when you look up, it's going to be there day and night. It tracks along with us. Geosynchronous does not. So NOAA, our weather agency, has just switched from polar satellites to geosynchronous. So I was invited next week to view the last satellite going up with the new system, and it's called GOES, GOES. And it brings us down live transmission over the internet, and those who know how to handle satellite dishes, every 20 seconds in many formats, in visible format, infrared, ultraviolet, and so on. And then what they call sandwich, which is mixing them all together. So anybody can get the weather now, just like the newsman does, on your computer. And it's 20 seconds old. So if you want to know what to do tomorrow morning, travel or not to travel, whatever, you can actually get a picture on your computer and print it off if you want of the weather, and it will show you as it moves. It's live and it's dynamic, so you can see a storm coming in from the Rocky Mountains and as it's coming to Texas, and specifically we're here where we are in Central Texas. So anyway, that's the technology of on the moon. Now it's not only United States and China, but Japan has also put a spaceship on the moon. India also put one on. So we're in a race now with 4 or 5 different countries. Russia's tried. The last time they failed. They're just like us. The technology is old, and we have to learn new ways of doing it, and it's not that easy to learn. So we'll go through the trial and error just like we did with Apollo. So sitting in front of me here, what I'm moving is a new telescope from China. These are called smart telescopes, usually made by young Chinese engineers, very, very good engineers. Well, our telescope brings us into a whole new world. An old telescope, the tripod down here, I've got my hands on it, is big and heavy and bulky. Okay. The mount is big and heavy and bulky. It's got the reflector case on it. The OTA, optical tube, is big and ball and expensive. So they're monsters. So a lot of people don't try to learn it and give up on it because it just isn't. As one of my friends say, his telescope became a coat hanger. That's because people bought them by the hundreds. Kids bought them. but they would not put out the effort to learn how to work it. Well, most of that now, thanks to the drone industry, this telescope has got in there. So this telescope will do photography, it'll do video, it'll do tracking, just like the drones have done now for probably 10 years, and so on. So it'll do image stabilization. So it doesn't matter if the table waddles a little bit. It will handle a lot of the problems that you had with the old systems. One of the reasons the old telescopes had to be so heavy is because it had to be firm. When you're looking millions of light years out in space, if you touch the telescope, it probably takes about 4 seconds to stop wobbling, and you won't see anything on the screen. So you have to have everything electrified and so on. So that's where we're at now. Now, what I wanted to do was show you this. The other one that we have is called the Dwarf 2, and a couple weeks ago they came out with Dwarf 3. We have several of those in our system. They're nice, but we found out that it's a little bit tough in the learning curve for beginners. This one seems to be easier for the learning curve and also does a little bit more professional, at least from listening to professionals. So one other thing in learning this, especially in STEM and STEAM, is you're always going to want a new device. So we've been teaching for several years what is called 3D printing. It's called additive printing rather than subtractive. When you whittle a piece of wood like Huckleberry Finn used to do, you would subtract from a piece of wood from a tree, okay? Well, in this new manufacturing system, you take a thread and you do certain things with it and you print out what you want. So you're adding and you're not making a lot of waste, generally speaking, that the old manufacturing system did. So on here, you can see this white thing on the tripod here is a printed holder that we've got on the leg there. I can turn it around. That will hold my cell phone. Right, my other cell phone there. No. Anyway, I don't want to fold my cell phone. I've got the newest folded cell phones, but only certain ones fit in it. That probably won't fit.
Mine's the big one.
So we're teaching the kids to use Tinkercad, which is a beginner's program in computer assisted drafting and so on. This was made for my phone, so your phone may not fit. However, all I have to do is go in there, say I want to make it 50% bigger. I'll just click 50% and then print it out in half hour. I've got a new one. So this is what NASA is doing heavy duty now, and we're doing in the United States. They expect to be doing 3D printing on the moon. They're going to 3D print the landing sites and so on. But what I'm going to show you here is basically what we're teaching the kids to do with 3D printing. I showed you one. Here is a 3D printed circle. This has got threads on it, so you can have nuts and bolts and screws, just like you do in steel. And on here, you can put a small. In this world of astronomy, you've got 1.25-inch lenses and 2-inch lenses. This is a 2-inch lens. Here's a tilt solar for the eclipse. It came with this telescope, and you can see it's 2 inches. Okay, so this will take a 2-inch lens like that, and I can put on there the 1.25 lens from all my telescopes. Most people do not go into the 2-inch. The professionals do for better resolution, but they're using the 1.5. So most of the amateurs have 1.25-inch systems. That was 3D printed. Here's another one that fits. It's got a square. This is 3D printed. These actually will fit this telescope. You don't screw in for whatever reason. You just insert it, which you'll see later. You insert it into the tube. That's where the lens is. And now we can put a slide in here. So what you'll put in there, it probably is a diffraction grating to do a spectroscopy. It's squared, and you take a 35 millimeter, that is around 35 millimeter, put a 35 millimeter piece of film in there, and now it's on your telescope. This is a lens hood. Okay, you use that as what they call a dew hood. When you're out in the wintertime and it's cold, and most people leave these things out all night long, and they run it all night long because one image is not enough for the kind of resolution you want in astrophotography. You might have, I'm not sure how many this one does, but the Dwarf will do 999 images. So you just let it sit there all night long, take an image, and obviously it has to track. So this is 3D printed. And again, you can see the standard colors for astronomy equipment is black, not too good. You can't see it in the dark, so white is better. So you tend to print things that are white. All the things that we do, like this ring I got on, is glow in the dark. So we print things that will glow in the dark because you're in absolute dark on a new moon night. You can't see anything. So anyway, this is a filter. It goes on the front like that. And you can put lenses in here. You can actually, some of them, you can put a heater in it. So anyway, that's pretty much the Seestar. This is made by Zoe, Z-O-E, camera company from China. They may have been making astro cameras for many years. They're well known in that world, and they're very professional. So let's see. This is number one. Okay. Have you got this working or not?
I don't know. This one's working. I know yours was.
Okay. This is a tablet that we're using. The reason we use this tablet is because it will plug into HDMI. So, and you can also use a holder like that. So very nice. One of the problems you're going to run into with this particular one, for whatever reason, I think this is made by older engineers, and you can see I'm not young. So therefore, the old generation tends to think a little bit different than the new generation. And I've gone through 4 generations now. We're into the 4th. So I do know that there are some generation gaps in our thinking, in our education, and in our learning processes. So I was in photography for years. I actually had a photography business here for 10 years and took people photography, senior pictures, weddings, and so on. So, but I did medical photography for 25 years, and that was my field of research, optics and electronics. So this scope here's got one major flaw, in my opinion. It is portrait mode. We moved into the new high definition television. I'm not sure when, but probably 10 years ago, we moved from portrait into landscape. The Dwarf telescope from China was designed by young engineers, collegiate students. So it is wide. So obviously now we're used to wide and not portrait. So if you look at the sky, generally speaking, is better to have things wide, in my opinion, because you can have 2 or 3 stars or 2 or 3 objects in a view, where this way, portrait mode, you're probably only going to have one, and you can't change it. That's one of the problems with this telescope. But the professionals seem to like it, so they're happy with it. So now I started teaching this to some of our young students, STEM students. at least 7 or 10 years ago. It started with a program called ICE by Microsoft, image composition. So instead of doing one, you start adding one on the side and one on the thing. Then you start adding one above and one below. This is common now in drone mapping. You have to do it. You have to know how to have them overlap, or this one will not, it'll get blurry and you won't have one picture. Or panoramic picture where you're going to go 360 degrees. So now these are called mosaics. So in the world of astrophotography, they've been doing mosaics. Why don't you turn that down? I'm afraid we might be getting feedback. Just a sound. Yeah.
There we go.
Okay, I have him with me. That Colin, just so I wasn't sure we're not going to get feedback from that thing. Normally, if you look, most people have earphones when they're on Zoom doing this, so you can hear that way. But earphones don't work too good with me. I'm hearing impaired and visually impaired both, so I can use the earphones, but they're not good. So anyway, this is Connie Sanchez. Is that what you go by or not? That's her email.
Well, marriage name is Munoz.
Okay. So anyway, she's going to help me translate
To the best of my
this
ability.
into Spanish, because we are going after in astronomy as much as possible. Here's the map for On the Moon again. And these are all the registered sites. So we're on there as a registered site in Central Texas. And I think they took us off because tomorrow night we're doing one in a library in Harker Heights, one of our bedroom cities nearby. And the librarian registered, and I think put it on instead of having both of us, because we're doing both programs, they put that up there. So if you look on the map here from the website On the Moon again, you'll see, and they've got all the sites. So what we did is pick out, and I don't know if we'll get it done tonight or tomorrow or not, but what we're going after as much as possible is Central Time Zone, Central Daylight Time Zone right now, because we're in daylight time. In the winter, we'll be in Central Time Zone, USA. So that starts up here in Chicago with our people, goes all the way down through Mexico, Honduras, Guatemala, Colombia, and then over in the coast there, not Brazil, but Chile and Argentina. So there are people registered there. I'll put that up. So here, this way, you would click on those people and they tell you who they are. So we're going to make a mailing list and mail to these. Just so those who are watching this channel right now, we do have over 11,000 followers. So we've been doing this about 15 years, and we do have a good following on this. The last STEM program we did on Sunday and put up, we had 11,000 people look at this. So we've had How to Dance La Cucaracha, which is our most viewed video. We've had over 500,000. It's 500,000 viewers. So we're very happy with it, but we'd like to get more in the Spanish-speaking world. So anyway, what I'm going to do now is see if we can plug this guy in here, and we'll go through setting up a scope. Okay. This is number one. What number was that?
Number one.
Number one. Okay, that goes to number one. So let's keep number one together. And I did forget to go through one thing here. This is fairly important for people who are moving into this. You can 3D print your own, or you can buy them. but you have to learn a new thing. Okay, you're going to learn new terminology. This fits on top of a lot of telescopes, and it's called a dovetail. So more than likely, if you look on YouTube, a dovetail, you'll get the right one. There are a couple variations on it, just like everything in life. Somebody likes to make a minor change, but this fits over our lens here, and then you can put something on top of it. We didn't get it done, but I started working on it. But we're not there in our teaching sessions. Is a laser pointer. A laser is being used to point at stars when you're at an outreach party, and we're going to put it on here, and that way you don't know what you're doing here at all. So when in the dark, you've got to go completely by the tablet. So you can put that on there, put a finder up there, or you can put a laser, and now you'll see the laser point. It goes off probably up to a couple thousand feet, and you can point it at the moon or the star if you want. So it's a fairly important thing. One other thing I want to go over is if you get into this, you must learn the physics of light. Okay. If we get to the outside part and it's working, you'll see across the street is a church that's lit up like downtown New York or downtown Chicago. Then right next to them are 10 or 15 businesses. So not only are we in a light polluted city, but in my backyard, it's light polluted. So these new telescopes do have a light pollution filter in it, but you've got to understand what that means, and we can teach at some point and show you what that means and so on. They don't work for me. So what you do is buy a good filter. Sometimes these filters cost as much as a telescope does. This one's $175. And this is what you call a dual band narrow 77 millimeter, which means your bandwidth only 7 millimeters. So there's 25 millimeters to an inch. So you can see where we're down. There's less than half an inch. Okay. It only let through something here, a light wave, and another light wave up here, and everything down here, it blocks out. So the sodium light in street lights, the lights from bulbs and so on, will be blocked out, and only the light from your star, your galaxy, or your nebula will come through. So you buy these and zap them in. However, I found that for whatever reason, even without the filter, my telescope will do fine. So last night, now listen close. I want you to translate this if you can. Last night I was practicing for this. I practiced for the last 2 weeks, outdoors, indoors. Most of these are on YouTube. You can see them and participate in them if you want. But anyway, I did 3 things with this Seastar outdoors in the light polluted backyard. So what we're doing now is backyard photography. Backyard astrophotography, which is just unbelievable. That used to cost thousands of dollars. So what I want her to translate is the 3 things I got. 1, I got Cigar Galaxy. Okay, 2, I got Vega Star. Vega is the brightest star. Okay, and then 3, I got a few other things I looked at, but the main thing was that because I want to talk about. So translate that in Spanish. Cigar Galaxy in a light polluted area.
Cigar Galaxy in a light polluted area. Área cigarro Galaxy Aria Sacada. Lo que intentó hacer es trató de agarrar fotos de estrellas ayer afuera y agarró 3 tipos. Y uno se llama, what's the name of the first one? That you,
Of the star?
yes.
Vega, V-E-J-A.
La Vega Estrella. What's the second one?
Okay, the second one I got was Polaris,
Polaris.
which is the North Star.
Es la estrella del norte.
That is what everybody uses to set up astronomy
Y
equipment
eso
on.
es lo que todos hoy usan para empezar la localización de
Okay, I
lo que van a
test.
hacer.
Go ahead, look at me when you're
And
done.
the third one?
Look at the camera, then look
Okay,
at me. That way
the
I
third
know that. Okay. Okay, Vega, as I said, is brightest star, so it's an easy one to get.
Y Vega es la última que encontró, que es la más brillante
Okay.
y es muy fácil para encontrar.
So I did test it today and put it into my spectroscope software.
Y sí, pudo agarrar esas imágenes, perdónenme porque también estamos aprendiendo a
The
hacer
one
esto.
that we're using is a paid one by Tom Fields.
El que está usando para poder hacer esto se llama
Okay, and it's called RSpec.
Fields.
So it's very, very nice, very easy to learn, and Tom Fields will help you learn it if you have to, and it's relatively inexpensive.
No cuesta mucho este tipo de programa y es fácil para usar.
And to some extent, it does include infrared and ultraviolet, which is important in astronomy, especially your infrared spectrums.
Tiene espectro rojo que ayuda a ver. También, what was the other one?
Ultraviolet.
Otra.
Okay. Now, infrared, most of you are familiar with. Infrared is what we use for night vision. If we get it working here tonight, we will have an infrared camera and infrared lights, which basically you won't see. Many of the clickers that people are using, the ones that we will use, the clickers for TVs, put on an infrared light, so you won't see it. Our eyes do not see infrared. So if you want to see if it's working, shine it in the camera on your cell phone and you'll see the infrared light. So that's one way to test your clickers. So anyway, we did put it through the spectroscope and we got a nice spectrum out of it, out of Vega.
You want me to translate all that?
Vega did give me a nice spectrum from red to blue.
Si logramos verlo, vamos a poder verlo. Si está indicando que si uno no sabe si se puede ver esa luz, usa uno su teléfono para poder ver que si la luz está usándose, que es con nuestros propios ojos no podemos verlo.
Connie's at a little bit of disadvantage here that she's not an astronomer.
Como no sé mucho de astronomía
hope to make one out of her.
Y tampoco muchas palabras todavía de este tipo de...
And her daughters. She's got 3
este tipo de...
beautiful daughters that have worked with me in music and dance and some technology in the past. So
voy a estar aprendiendo poco a poquito con ustedes para poder darles esta información en español y también al mismo tiempo el entender que a veces uno debe ir más despacio para poder darles la información en español. Pero ahí vamos aprendiendo. Por eso esto es la primera vez que hacemos esto. Y yo al mismo tiempo estoy aprendiendo las palabras que usan en ciencia para astronomía. Y Dios quiera que en unos días el proceso vaya a ser mejor para poder dar esta comunicación para ustedes.
Connie is a Mexican-American. I've known her for many years here. I picked up her daughters probably about 7 or 8 years ago, I would guess now. So when we moved from dance into STEAM, we were teaching only the arts under Mecca. And then under STEM, went into STEAM, we combined the two together. So anyway, I was trying to think how to do this. What I need to do, if we can work it, is I think, Roy, if you can do it without problems, get the HDMI from camera 2, the one up top. We're going to go off camera now and see if that HDMI cable, just take it up. Is there HDMI in the back? Yeah, pull it out. No, I want the cable. Yeah. There you go. Okay. Okay, see, we're going to go off there in a minute. I need that cable here. Plug it in here. And cameras 1 still on. So Roy, push the first button there. No, there. Is it? Okay, now push the button, the last one, the way you did before. Okay, now we're on. Now plug that HDMI into here and see if we get a picture. One of my problems is that my switcher here, I first bought the wrong switcher, so it's setting in a box. And let's see if we go. Good, we're on. Okay, we're up there. We're on. And as I was saying, it only takes 4 inputs. And our sister system here has gotten past the 4. It's a little bit more sophisticated. So the next step up is to 8. And I'm buying all these new telescopes right now. We got 5 of the dwarfs for the eclipse. Okay.
It's okay, Roy. You can keep it there.
Okay, good. Roy's keeping track of us. So,
that's not
yeah.
good. Oh, is that a delay?
Okay, just remember
That's
that's
a
20
delay.
seconds late. So,
That's the delay.
okay. But right now I'm putting the money in the telescope. But as soon as we get that done, the next program we'll be doing, if anybody's listening, is we're trying to work up an audience, and hopefully this will come through the internet. Our sound is a little bit low for some reason, so we've got to work a little bit more on that. But it sounded okay coming through. That will have a following that will be live with us. We don't want to do Zoom, but we'd like to have chat. So we can do chat on both Zoom and on YouTube. So we didn't set it up for chat, but it will come up. So there's no setup, but we have to have somebody sitting there, another person following the chat. So we're not ready for that yet. Our team has to get bigger. So now what I'm going to try to do is show you how to set up this telescope as much as possible. Okay, Roy, now the far button to go back and forth, all you're going to have to do is flick it. So flick it. And there, now you won't see us, but you'll have to see it as I set up the telescope. Okay, now this is the menu for this particular one. So most menus are pretty much the same for phones or tablets or PC when it becomes a tablet. So they have the swipe pinch and so on. So we're going to go up. So the first thing we have to do always is go to settings. So we'll go to settings under S. And like it or not, most of this new technology depends on Wi-Fi. So most people and teachers do not understand Wi-Fi well. They'll put 5 drones in a gym and don't understand why one kid is flying somebody else's drone. Well, it gets very complicated. Wi-Fi, most of the drones are on N protocol, which goes back to 2009, and we're now into 2024. So anyway, we've got to set it up on my network here. Settings. Connie, you're going to have to watch this. So
Yes.
network. And the network is the same as our logo, MechaTex. So it's Wi-Fi, MechaTex, and we just need to make sure we're connected. And it says connected, unmetered. And again, you have to understand to some extent these devices, telescopes, are going to get on this network, but they have their own network. So they will put out their own network. This is where it gets a little complicated trying to understand some of this. Okay, so now we're going to go back, and it just so happens that C star is right next to setting. So we lucked out. Now, when you use a dwarf, it's not so easy. So we're not going to do the dwarf. But anyway, C star, if you look at settings, now we're going to go through that. So turn on, now there's a button somewhere. You see it?
Oh, I see it. Okay, turned it on.
And most buttons now, okay, that's okay. You have to push them. So there's a button on there and hold it, and it should come up if it's fully charged with five bars. 1, 2, 3,
Four.
4. Quattro. So anyway, now you can see, you wait till it gets on, and
powering on, ready to connect.
It's nice that this telescope talks to you. Again, good thinking. And hear it very well. I can hear it, but I don't know what it's saying. So I've got to get my translator there. But while the telescope is working, you just sit there. So you've got to find some things to do. So last week I got the idea from another guy in that I always buy 2 of everything because I always have a backup. That I was taught a long time ago in the Army. And if you can afford it, you do not do anything. So everything in life is done. Generally speaking, on TV, there's always a redundant channel. So it just so happens that I always buy 2 of everything, and I have 2 networks going here. So I have 2 of the C stars. So I've got one for me and one for her.
Thank you.
So she's going to learn how to work it. And she has a daughter in the Army going to Kuwait. And I spent 34 years in the Army. So I looked at the sky in Korea for 17 months. Looked at the sky in Panama near the equator for 5 years. And looked at the sky in El Paso, Texas, San Antonio, Killeen, Denver, Colorado, you name it, California, Virginia, and it never ceases to amaze me, and I can spend a whole night just looking at the sky. But it's good if you learn the sky so you know what's going on. Otherwise, it's just what we call the wow factor. You look up and you see something, you say, wow. If you look up and know what it is, you can say that's God's painting in the sky. So beautiful things you'll see with the telescopes and so on. So we have two of them. Okay. So anyway, now let's turn down. So it has to lock into the network. And then now my tablet has to lock into the scope. So if you watch very close, you might be able to see all this happening. And touchscreen is nice, but they're still a little flaky. But there now we have the screen come up. Okay. And there's a very nice screen. I don't know if it'll sit like that, but you can see it is. Let's see. I'll hold it a little bit.
I'll hold it.
Yeah. Okay. Connie's going to hold it for me. So now you can see the screen in portrait mode. And it says, it just so happens that sometimes the screen is bigger, so you've got to know when things are hidden there and so on. So this is done very nice. So this part of the software, again, is extremely user-friendly. So, Roy, I think you might want to turn that light off. Yeah, go ahead.
You're gonna have to really
Just go under
be
it,
careful.
can't you?
Here, I'll hold it. I'll turn it off.
Okay.
Yeah. I'll turn it off.
I don't know if they're seeing that, but I'm seeing it here. So, okay, there. Good. Okay. Got it? Oh,
You got
tip
it.
over. You got to be very careful with all this stuff. We're going to go back, see where we're at.
Right there.
Okay. So at the top there, you'll see stargazing. You'll see solar. We're not going to do any solar. We got our fill of that with the eclipse. And then lunar, and we will be doing lunar tonight or tomorrow. I'm not sure we're going to get to it tonight. We're moving a little slow. And then we've got planetary and scenery. So this is something too. These telescopes, most of what you hear about them is for astrophotography, but they're good for bird watchers, people who track birds. They're good for butterfly watchers. They're good for a lot of the people who are on terrestrial telescopy. One thing you do have to understand if you're a beginner, terrestrial photography, a telescope, the image is upright. In astral photography and astronomy, your image may be upright or right or left or up and down and right and left. So you do have to train your brain to think a lot different. The best example of that is Cassiopeia, the queen of the sky, right near Polaris and right near the king, Cepheus. At one point of the year, let's say winter, she may be a W. And then she's going to go to the right. And then in the summer, she's going to be on top and she'll be an M. So in learning the sky, you have to kind of change your mindset that up is down, down is up, right is left, and left is right. So it becomes a real problem. For the new smart telescopes, they've solved that for everybody. So you don't have to kind of go through that, but you still have to learn the universe that way because that's the way God made the universe. We can't change it, but we can change the telescope and the technology. So anyway, what we want to do is set this up. Okay. Down at the bottom, you can see it. Can you hit that me? That's me. You can see different stars over there. Stargazing star, and then I have one to find a star, find an object. The database that's in there, that thousands of objects are already in there. So you just need to find it, like Vega, a star, click on it, and a telescope will go to it. So But here you can see the bottom if we want to turn it off. I'm going to turn the do on. Okay. Now, I ask this a lot of times to the kids, what's the most important thing in your life? I've yet to find one that can give the right answer. Most adults probably can't get the right answer. The right answer is your location. Just think about it. And then comes trigonometry, algebra, land navigation, sluice navigation. That comes with what all mid schoolers need to learn. A square plus B square equals C square. By high school, every student should know that, but they don't know probably what comes after that. And we teach it, it's called the circle of units. From the circle of units comes a sine wave, which is your red, your green. And all this is mathematics. So in STEM, we are supposed to be teaching science, technology, engineering, math. I find that most people somehow do some technology. They think that's STEM. Very few of them teach the math, and very few of them know it. First thing you have to realize in astronomy and aviation and nautical, your sailors, is that a land mile is not the same as a celestial mile. This is where the math comes in. The earth is curved. Therefore, all these things I talked about there, your mile is curved. So a curved mile is longer than a straight mile. Now, this obviously should come through to the drone people who fly drones or airplanes. If you're calculating the weight or the gasoline versus the weight of any flying machine, you must not use land miles. You're going to run out of electricity or you're going to run out of gas. And somebody's not going to be very happy. You're going to lose your drone or lose the airplane, whatever. So basically, we have to teach celestial navigation and these, the mathematics goes with it. It's called orbital math. And there's a formula for this. People want to look up Haverson's formula, Heverson. It's how to turn a land mile into a spherical mile. In other words, how to turn a right angle into a right angle in a circle. So that's enough on location. You've got to know where you're at. And in our world, that little z is latitude and longitude. Interest enough in the sky is pretty much the same. On the moon, tomorrow we'll have the children playing with latitude and longitude. Okay. So now I'm going to have Connie do it. What this telescope has to know, it has to learn where I'm at in this world. I'm in Central Texas. I'm in this house. I'm at this little spot. And then it's a matter of how close. 1 meter, 2 meters, 10 meters, or a football field. So this is where you have to understand, again, the technology that if you're doing mapping, you generally speaking have to be within a meter for sure. If you're doing some things, doesn't matter if you're within a football field, okay, 100 yards, 10 yards. It's better to be within 1 yard if you can, or 1 meter, which is 3 feet, which is basically a little bit more than 3 yards. So this is what all the kids have to learn, the math that goes with all that we're talking about here. So what we've got to do now is take this telescope that's got a built-in electronic compass, and you have to do this with drones too. So anybody who's flown drones can easily move into this new world of astrophotography. So I'm going to do advanced features, hit the little arrow. Okay, now hit compass, calibrate. Okay, now look at the screen very close. It comes up with the Sea Star. This is beautiful, very simple, very easy. Now she's going to hit calibrate. And now I'll hold it and pick up this and do a 360-degree turn. And you'll watch this as you do that. No, go this way.
Okay.
There is sometimes a difference between clockwise and counterclockwise. Okay, it's not there yet, so do another one. And hold this. It's having some trouble. I'm not sure why.
It's going. Do I keep going?
There may be some magnetism in this room. We've got a lot of radio waves going through here. Okay, it's done. Now you can see it's done. So kind of set it. And I'm going to say complete. So now we've said, now the telescope knows where it is. Just like I know I'm sitting in my house. Connie knows she's sitting in my house next to me. And so on. So the telescope now knows where in the world it is. So I use this as an example to the kids once in a while. If you go to sleep and you get on an airplane or whatever, and the airplane ends up over in China, and you wake up, you're in a world of trouble. And you're not going to know where you're at. So you're going to have to use your senses again, a compass or something to say, look, that sign is Japanese, or that sign is Korean, or that sign is Chinese. So that's what this just did. Now comes the hard part. I'll hold it.
Okay.
Now, let's see. Maybe let me do this. This is a little tough. You take this guy.
Mm-hmm.
Can you?
Mm-hmm. I'll take it.
Yeah, we
Oh,
should
the
have.
Jedi move.
What I want is this here.
Okay. Hold it.
Yeah. Cute.
There we go.
Why don't you move up closer to Roy?
Roy, that was a Jedi move.
Okay, now
What?
That was a Jedi move right there.
I'm trying to figure out why on that camera we lost
Oh, press the
number
other.
one.
Press the other one, Roy, because so we can go back to showing this as number one. Mm-hmm. There we go.
Yeah, but that's not us.
It is.
Somehow we got clicked off. What do we got over here? Go back there. That's okay, Roy. Go click. Somehow we lost the prime camera number one, so that's okay.
Yeah, we lost
Okay.
it because we took the cable out. Took this cable out.
Out of where?
You took it out.
No, I don't want that camera.
No, you took
Okay.
the cable out.
Okay.
That's why that
Okay,
camera-
what I'm going to do now is do leveling. This is where this math comes in.
Mhm.
In astronomy, you've got to look straight up at the sky. That's called the zenith. That's a 90-degree angle. So if you look in this house, you'll find almost everything is at a 90-degree angle. No,
Click the other one. Click
Wait,
the other
just wait and see. If it
one.
comes back to 20 seconds. Just
What-
wait. There
we go.
We're back. We're
Yeah.
still going. Okay, so this is where this a square plus b square equals c square comes in, a right angle, and then the sine and the cosine, and on occasion the tangent. Okay, you've got to have a right angle to be level with the horizon. So this is a tangent across the earth. Okay, where 7 miles from now you're going to lose your line of sight radio wave, because the Earth is curved. So this is where this becomes very important on leveling it. So now hit the level one up there.
It says adjust level.
Adjust, yeah.
Please
Okay.
level your sea star.
Okay, now this is a level just like engineers use and people use, a bubble level. They put in there for you. And you can see it's registering at 5.8. That is not good. You want it at 0 or as a minimum 3. Okay, so 1.9 would be okay, and so on. But this telescope will not work unless it's level. So now I've got to take the tripod down and move some things around. So now we're down. Normally, also, you should take your telescope and point it north. Okay, as a general rule, you're going to zero in on the North Star. Therefore, you point it north. Now, this is a real, what I call pain in the neck. It's hard to get it leveled, but that's just the way it is. So you've got to make sure, if possible, you're on a level floor or level ground. The ground outside is not level in my backyard, so it takes a little bit of playing with it to get it level. So, but you got to take one side at a time and loosen it until you can see there we got down to 3. Okay, we're not making it very good. So that one's not it, so I tighten it back up again. And see if this one is going to give me any better. I loosen it. And that one's not doing it, so let's go back to the original one. And you can see now what people have bought, and I've got them, but I haven't learned how to do it yet. 11, we're way out. There's a leveler that's a little bit easier to use that goes between the telescope and the tripod. I hope here. Let me get rid of this thing. And it'll say this is where setup comes in. You just have to do it until you get it set up. And we are in a house, so it's tending not to like it. So maybe we'll need to go outside and do this out. If I can get one side zeroed in a little tighter, then you can work on the second one, but we're not. And I say when it looks level, on the thing, it won't look level to your eyes. Huh, we're not getting there. I'm not really sure.
We're at a 2.1.
Yeah, a little closer. Now, if we can. You can see how touchy it is. And this table is a little funny too. There, we got 2.9. again, a table that bounces is not good. Just what I talked about earlier. Well, there. Well, we almost had it. What a lot of people do on YouTube that do this is they do a fast forward here. They don't have you watch all this, but we're not set up for this on a live one.
Oh, you almost.
Yeah. See, the problem is as you turn
There we
it,
go.
it locks in. Well, I think we're going to go there. So. Okay, we're going to stop. That's 3.9, 4.1. That's not good enough to get the moon outside, but anyway, we're not doing the outside right now. Okay, Roy. I was trying to think here. Do we have any of the cameras working?
Roy, are any of the cameras
camera?
working? What
No,
cameras?
we lost both cameras.
What do you mean?
Yeah. Okay, Roy, turn on the light. Let's
Oh,
take a
careful.
or Connie, turn on
Yeah.
the light. Let me see what got disconnected.
Maybe we need to just set it down. Otherwise,
Yep.
I was going to have it set down.
Yeah.
Just lay it down for now. I
Yeah.
gotta go see why we lost.
You took this out.
Okay, wait.
It was there.
Wait, we got camera one now. There, look. That's what I wanted. That's camera one. That's the one here. Okay. Yeah. Give me that clicker over there. Okay. Technical problem. We need a bigger team of people here. So anyway, yeah, I'm checking myself. Okay, now push the far button. Put us over there. And here we are again. So here is a telescope that I've been working. Find my thing if you. And I'm going to turn it around for you. So you can see there. Okay, here is the little lights. Okay. Okay, I'm going to wait to see if I can see it over there.
You're at a 2.4.
Yeah, but that's a preview. We should be seeing this here over there. Well, let me go look and see what. I don't know what the problem is. All I can think of would.
We're at a 4.3. I think we're just behind because we're at a 2.7 right here.
Well, let's stop for this. I don't know what the problem is. This is a YouTube problem now. We should be getting that picture. What we're sending out is that picture.
There we go.
Okay. There.
More than
It's going slower
For like
for some reason.
40.
Okay, we're back. So, Connie, some Spanish.
Hola, ya volvimos. No, en verdad, perdónenme, porque estoy aprendiendo aquí con ustedes y tratando
Take that one.
de ayudarlo a poder explicar estas cosas en español para ustedes. Yo todavía estoy
All right, can you
aprendiendo,
hold
como
that?
dije, las palabras en español.
There you go. Now we got two of them.
Y nomás
Move
necesito
to the
paciencia.
side so it's not in front of you, however, there. Okay, don't have it in front of your face. Can you?
Like that? Look.
Yeah, okay. Okay. So now what I want to show you here is this. So let me see if I can do anything here. What I want to do, if I can, and we didn't get it leveled, but we're going to go back to
I'm the Vanna White of astronomy. What?
okay, I'm back on my tablet trying to. Okay, I'll hold it a minute. Okay, keep. No, we lost it. Too much technology, just like I said.
Okay.
We need a lot more practice with this. But anyway, what I wanted to do is show you with the scopes. Okay, you're not going to be able to see it. This part of it here on the back side is your optical tube. This is your telescope there.
Este es donde está la
This is going to turn and face the North Star if it's pointed at the North Star.
Eso es lo que se va a
Yeah.
voltear y va a apuntar a la estrella del norte.
Okay. So I usually take this and sit here this way so I can see the on-off button and the battery.
Él normalmente así lo pone para que él mismo vea que está prendido
Okay.
y cuánta batería tiene.
One, the battery only lasts so long.
La batería solo dura cierto tiempo.
That's why you can use one of these, put it on the leg, and use a power pack.
Por eso
So
puede
you can
usar
plug a power pack in.
esa cosa que puede detener, donde puede conectar para que le dé más batería.
Also,
También
the lights tell you the charge, so you'll know when it's going
las
down.
luces de atrás
And-
les dicen cuánta carga todavía tiene.
And the on-off switch will tell you certain things too. Like when it's starting, it's not uncommon to have to do a firmware upgrade, and it will blink yellow. So those are certain signs. So just like in the drone, there's certain lights that tell you some things that you do need to watch. That's why I sit here and watch it.
También el botón que es para prenderlo indica ciertas cosas como si está brillando y está dando que se prende y se apaga. Está indicando que necesita que lo hagan update. Pero también como está tratando de explicar que las luces del botón para prender indican que se necesita para esta máquina.
Okay, for those who may be watching, I don't think we're going to get to the outside part.
En este momento no vamos a hacerlo de afuera,
But we are going to be at a library tomorrow with an outreach at a library that's open to the public. So we've done this in the past, and we get a decent small size crowd there. So we'll be starting there the indoor session at 7 p.m.
Mañana en una librería vamos a estar haciendo algo así y va a empezar a las 7. Está abierto para el público.
and outdoor at 8 p.m.
Y afuera van a tener otra, ya que se haga más oscuro, a las 8 afuera.
While we're setting up these scopes, and you can see the problems we're having, we're going to have some of our young people, our youth, do some performances.
Y mientras están allá van a ver otras cositas, como van a ver ciertos adolescentes que van a hacer cositas como cantar o explicar ciertas cosas. Pero mañana nomás les quería decir que se llama Skywatch Party. Va a ser en Stuart C. Mayer Harker Heights Public Library. Y como dice, va a empezar a las 7 y a las 8 se va a hacer afuera. Pero mientras estemos haciendo eso, como dijo, va a haber estudiantes o otros adolescentes haciendo otras cositas para entretenerlos.
One is going to do a dance called clog, which is old time Texas clogging. It came over from Ireland with the Irish to Texas or to the United States and made its way down to Texas. So this young one was with me before and she learned to clog with us. So clogging is popular across the United States. So she'll be doing clogging and she'll sing some Texas songs.
Vamos a tener una persona que estudió mucho con él también. Ella va a hacer un baile que es de irlandés y usa unos zapatos para hacer este baile. Ella también va a cantar una canción. En el estado de Texas, esto es algo popular que hacen. Y esta muchacha en particular lo ha hecho por Mecatex en el pasado y lo va a hacer mañana.
And Connie's daughter,
pues mi hija,
will be singing Blue Moon.
Va a cantar una canción que es de la luna, como están tratando de hacer canciones que van con lo que estamos estudiando de las estrellas y las lunas.
Connie may sing a moon song for us in Spanish.
Y si Dios permite, voy a tratar de cantarles una canción de Pedro Infante en español, que asocia la luna, que es de la luna.
Us old timers, the way we did nights out was always around a campfire at a beach or out in the ranch somewhere, and we would have sing-alongs. Sing-along moved into karaoke, and now we still sing some of those old songs. I grew up with Blue Moon, Sailing Along on Moonlight Bay, several moon songs that we try to do. If we're doing something at the planetarium here in Killeen with them, we usually try to do some music before Under the Stars. So the planetarium that we have in Killeen, they actually say Under the Stars, Texas Under the Stars. So we'll be singing the song Deep in the Heart of Texas, The Stars at Night, Big and Bright, tomorrow. And this will be our performance while we're doing our setup for our guests who are there. And they can sing along with us if they want. So we will be setting up tomorrow, hopefully 2 sea stars. For the last 2 weeks, I've gotten that zeroed in outside. So for those of you that know that when you're depending on satellite signal, if you're in the house, the signals are not too good. And for most technology, you kind of have to have a signal from 12 GPS satellites to zero in. So I would guess that might be what the problem is here. We've got cameras all over the place. We've got phones and tablets that we probably have overwhelming the electromagnetic spectrum, and the satellite signals are too weak to come up with the 12 signals that we want. Sometimes in the house, I actually have to walk to a glass window or a door to get 12 signals in the house. Outdoors, you'll always get them because it's all line of sight. So, okay, explain a little bit of that.
En pocas palabras solo que dijo, y voy a tratar de hacerlo lo mejor. Antes, en el pasado, la gente de su época se sentaba alrededor de una lumbre y cantaba canciones de sus tiempos, sus favoritas siendo Blue Moon. Entonces él trata de hacer eso, pero con karaoke, y es lo que vamos a hacer mañana, y cantar canciones que son de esas épocas. Y está explicando que él normalmente, a veces sí se pueden ver lo que estaba tratando de hacer, pero con tanta tecnología que tiene en su casa, cree que los teléfonos y las tabletas probablemente le han hecho, se le ha hecho más difícil para poder agarrar señal. Él aquí en su casa a veces debe que ir junto de la ventana para poder agarrar la señal que es suficiente fuerte para él hacer cosas. En todo eso que dijo, yo
Okay,
traté de explicarle un poquito.
As I said, we will be contacting some of these contacts by email
Como ha dicho,
afterwards.
sí va a contactar ciertas personas a su correo electrónico que están interesados, que ahí tiene quien ha sido preguntas o está interesado, y sí va a contactarlos por correo electrónico.
And you'll be able to see more or less what we're doing, which is just indoors, and tomorrow it'll be outdoors.
Y va a poder ver lo que estamos haciendo ahorita, lo que estamos haciendo adentro, y mañana lo que vamos a hacer afuera.
And then make a decision if you'd like to follow us
Y ahí
on
ustedes van a
further
hacer
issues.
una decisión si quieren seguirnos. Y
The next one I think will be, we've done that since 2015 too, NASA. This will be a U.S. program, whereas this on the moon is a French program. The NASA program would be called International Observe the Moon Night. So Observe the Moon Night, and I believe that's September 14th.
en septiembre vamos a hacer algo como esto, pero va a ser por NASA. Ahorita creo que es por Francia, de la luna, pero
For those of us in Central Texas,
por los que viven en
that
Texas,
is the 16 Mexican Independence Day
El 16.
weekend. So we may be doing some Mexican dances and music. That's a Saturday night. And I believe Monday is Mexican Independence Day, which here in Texas starts Hispanic month. So now, it's just not the Mexicans get the glory. Now it's Hispanic month. And some places they have turned that into other titles, such as Fiesta de Mi Patrias. I believe if I'm saying that right. Celebration of my parents and so on. So Hispanic month here does celebrate our Puerto Rican culture here, and also a heavy Panamanian culture, because a lot of us military were in Panama until it closed down in 1979, I believe it was. So the younger ones haven't been there, but us older ones, many of us has been one complete tour in Panama. I was there for 2 tours, 5 years. So anyway, our next program will be that.
el siguiente programa va a ser en septiembre. Va a ser algo durante la independencia de México, pero ya lo han cambiado a meses hispanos, y también los puertorriqueños celebran ya, creo que algo así. Ya se está haciendo más ese mes para la gente hispana. Él nomás quiere que sepan que en septiembre, si nos siguen y se quedan con nosotros, van a poder ver algo más como lo que indicó de NASA, y también va a haber bailes, y va a tratar de entregar también poner eso en el programa, donde va a haber música y también algo de los hispanos, si nos siguen y quieren acompañarnos.
Also, I'd like to thank Connie for joining us, because she's been with us for years, and but has never gotten into the scientific part of our world. So now she is, and I'm pleased to have her. We like to get our young people to speak Spanish, so we do a lot of things that cross over into the Spanish language because they try to learn it in school, but they're not going to learn it all in school. They need to learn what we call the colloquial terms, how people really talk, not
Yes.
what the book says, and so on. And there's different words for that in different languages. But anyway, you'll find that some words will be different in Panama than they are in Mexico. And that's why we hope to get people involved with that line that we're talking about, because we have addresses here for Guatemala, Nicaragua, Managua, Nicaragua, Colombia, and one of our members, the husband is from Colombia, and then through Chile and Argentina, and not so much further east, we would call it here, because then we're moving to a different time zone. And we do have trouble when we're trying to cross time zones. We're just not ready for it yet with the technology that we have, so it's much easier. So anyway, trying to check our time here. It is
And-
now almost 9:30, and that is Central Daylight Time, USA. So that could be Mexico, that could be Chile, it could be Argentina, it could be Colombia, it could be Panama, and so on. So it doesn't have to be USA, but it's a central time zone. For those who want to use, astronomy doesn't use these time zones, just like the pilots do not. Military tends to not. Marines, you might hear they use what they call Zulu time, Zulu. Time starts at degree 0 in London area of England. And therefore you have to know, again, your location. We happen to be lucky in that we're 97 degrees from London. So 90 degrees is 1/4 of 360. So let's relatively easily divide 24 by 4, and it tells me I'm 6 degrees off from London. Then I have to know which way I'm off, forward or backward. So when I'm dealing with China, for example, midnight here is noon there. So when we're talking to the Chinese people on Zoom or like this here, the bottom line is if I want to talk to them at 6 p.m., they have to get up at 6 o'clock in the morning and go to work to do this type of Zoom session. So this is where in astronomy, you're going to not only have to learn math, but you have to learn what I call the way of the world. And that is UTC, Universal Time Code out of London. So go ahead and say Universal Time Code.
Universo, si no latino, les prometo que voy a
Yeah.
aprender todas estas palabras para dárselas.
And we are 6 degrees or 6 hours. And that does change during the winter because we are on daylight saving time. So for those of us watching us on this chain that we're trying to make from Chicago to Chile, we're all in the same time zone, so it should be relatively easy. And if you need to talk to other astronomers, such as the people in France right now, and people around this from around the world, have said in France right now, they are about 6 hours different from us. China is about 12 hours. Germany, so you do have to know if they're ahead of you or behind you. So as you move forward, you're going to cross the international date line, so you move into a new day. So in England, they are starting a new day when we're still on the old day. If you look at the chart behind us, I don't know if you can see it, but this was one of our sessions on trying to show our young people what happens with the Earth going one way and you looking at the stars. And this you've got to get in your head as much as possible. the stars do not move the way we are. We and our telescope is what's moving. The stars are staying there. So Polaris will be there forevermore, but we are moving. So there's a lot of things that are being taught in the educational system as frame of references that probably are last century. We like circles. Therefore, we see a circle around the earth. We have a circle around the moon. Kepler's laws, if the kids are going to learn the three laws of Kepler, which they need to learn, Kirchhoff law, which I still know at my old age, the three laws of Kepler tell us that there is no such thing as a circle in an orbit. It's an ellipse. So if you watch any hardcore physics, moon stuff, you'll find that the moon has what we call a perigee. I would write this down as a key word. It will be on the keyword thing. And apogee. Perigee, the way I learned it, is perilously dangerously close to you. So that means the moon is close to the earth. 2 weeks later, it's going to be a long from the earth. It's going to be an apogee. So therefore, eclipses can only come at certain times. You can only have a new moon that does certain things and a full moon. So I'll just leave this with a thought. How can you have an eclipse? Is the moon going to be an apogee or perigee? It has to be between you and the sun. Okay, therefore, the moon is new. You can't see it. Therefore, it can block out the sun. So, as I say, I'm not sure where our young people are supposed to learn all this celestial navigation. And it's not only navigation, it's also in mathematics. Now we have for computer programming, we have programming that's done what we call digital colors. I've taught at a museum 2 years ago, colors to kids from the age 7 to 12. And it's called digital colors. So it's no longer with a crayon, it's with a color. So hopefully, as we go forward, we do have a decent following of young people, but we can't have young people without their parents. That they will come along and hear this. You have to hear it over and over and over to understand perigee and apogee, and so on. So looks like our air conditioner comes on.
Yeah, I can feel it.
It's getting cold. So normally I turn it off when we're doing something like this, but all this electronics gives off heat. And on one session a couple of weeks ago, we bombed out. It got too hot, and electronics will turn off. So it should be 9:30, and it's 9:35, and we're going to sign off. So say hi, Connie. Say hi.
We're signing
Bye.
off, and I hope next time.
And here's Roy
We'll do a
sitting
better job.
over here doing our technical work with the switcher and the cameras and all that kind of stuff. So tomorrow, as I said, we will be outside. And if we have decent help, I do have a young girl who's a whiz on the computer, but we need the computer working. And I'm not sure she'll get it on YouTube or not, but we'll try, at least for some of it. So anyway, we'll sign off as now. So Connie, I'm going to let you sign off. So Roy, can you change places with Connie?
Come on, Roy.
Take this out. Okay. And Connie, see if you can sign off. Look down at the bottom. It's relatively easy.
Yes.
And wait now, look over here. This is what we're doing. So watch and make sure it does what you tell it to do. So go ahead. I'm
End,
not sure what it says, leave session.
end stream.
Most things will say confirm it